And let's look at that cycle. The top part of this slide shows you the breakdown of glycogen to glucose and glucose to pyruvic acid, as shown in the previous slide. This occurs in the absence of oxygen. And if we were reviewing the previous slide, we would go over how pyruvate then forms lactic acid, and lactic acid gives us 2 molecules of ATP. But now we're looking at aerobic production of energy. And that means in the presence of oxygen, pyruvate can now enter into the mitochondria and form a molecule called acetyl-CoA. This is a 2-carbon molecule. So pyruvic acid, a 3-carbon molecule, is going into the mitochondria and forming a 2-carbon molecule with that 1 carbon splitting off as CO2 and being exhaled. Acetyl-CoA then goes through a whole lot of reactions. Each step of these reactions through what's called the TCA cycle and the electron transport system, and no, you don't have to remember that, but each one of these releases ATP. And that's why aerobic respiration results in the production of a lot more energy. So we have anaerobic respiration used for high intensity, short duration exercise, and we have aerobic respiration that produces ATP during lower intensity, longer duration exercise. So why is this interesting? We just talked about aerobic and anaerobic respiration and how those reactions occur. Let's look at how diet can affect production of ATP. When energy is coming from fat, for folks that are going on these really low carbohydrate diets and planning on using fat for energy, only the glycerol portion of the molecule can give us pyruvate and provide energy for anaerobic exercise. Remember, fat is stored in the body as triglyceride. Triglyceride has a 3-carbon glycerol backbone, and it's made up of fatty acids. It's only that 3-carbon glycerol backbone of the triglyceride that can form pyruvate, and that pyruvate will form lactic acid and provide ATP for anaerobic exercise. So fat is really an inefficient source of energy for high-intensity, short-duration exercise. The fatty acids, which make up most of the carbons of a triglyceride, are able to enter into the mitochondria as these 2-carbon acetyl-CoA fragments, and therefore provide us with a lot more energy, but only for aerobic exercise. Remember, it's only the 3-carbon glycerol portion of the triglyceride that can be used for pyruvate or pyruvic acid, and it's only pyruvic acid that can form a lactic acid and give us energy for anaerobic exercise. So the bottom line is that when you have energy, when you are expecting your energy to come from fat, only glycerol will provide you with ATP for anaerobic activity. And that's a pretty inefficient source. And studies show that people on the very low carbohydrate diets do not perform anaerobic exercise nearly as well as folks that are getting their energy from glucose. Folks on those low-carb diets are using fat for energy, but they're also using protein for energy. In the absence of carbohydrate, the body still prefers glucose for energy. Protein will be broken down into amino acids, and amino acids may be used for energy. We have what are called glucogenic amino acids, genesis of glucose, and we have ketogenic amino acids, genesis of ketones. Glucogenic amino acids can be broken down, the nitrogen is removed, and the carbons are used to form pyruvate or pyruvic acid. These glucogenic amino acids can be used for high-intensity, short-duration exercise because the 3-carbon pyruvate can form lactic acid. Folks who think that they're just using fat for energy during their high-intensity exercise while following these low-carb diets should know that they're also using their protein, and their lean body mass may be drawn on to provide energy during this exercise. Ketogenic amino acids are broken down into 2-carbon fragments or ketones, and these can form form acetyl-CoA. These can enter into the mitochondria and get broken down through all those reactions and form a lot more ATP. So ketones, or ketogenic amino acids, can be used for energy during aerobic exercise. But please keep in mind the body prefers to use glucose for energy. The muscle tissue prefers glucose for energy, especially during high-intensity, short-duration exercise. We'll talk in the next video about how after about 20 minutes or so, the generic person, of which there is none, will draw on fat stores for energy. But that doesn't mean you have to exercise for at least 20 minutes in order to draw on your fat stores. It just means that in that moment, fat is being used to provide the ATP for muscle contraction. What do you need to remember from this chemistry lesson? That anaerobic exercise is performed using ATP from lactic acid. Lactic acid is formed in the cytoplasm from incomplete breakdown of glycogen. Glycogen breaks down to glucose. Glucose breaks down to pyruvate or pyruvic acid, which forms ATP, which then can be used to provide energy for the contracting muscle. Excess lactic acid can build up in the muscle, and that can cause the tissue, the muscle fibers, to fatigue. That tells you to slow down. And when you slow down, the lactic acid then leaves the muscle tissue, travels to the liver, and resynthesizes glucose by the Cori cycle. Aerobic exercises uses ATP from complete breakdown of glucose. In the presence of oxygen, that pyruvate can enter into the mitochondria, forming acetyl-CoA, going through lots of reactions and giving us a lot more ATP. Also, the fatty acids from triglyceride can form acetyl-CoA and be used for energy. And I guess I want to tell you all this because, of course, it's important, but just to let you know that the low carbohydrates that a lot of athletes are using and are promoting as providing them with all the energy they need for performance is not based on science. Low carbohydrates, low carbohydrate diets force people to draw on fat and protein to provide energy for high intensity, short duration exercises. They're not an efficient source of energy. Now you can pick up your pencils or just watch the next video.